Hi guys, and welcome to this week 2 walkthrough of some of these questions then. So we'll start with introduction to ratio. We'll do a little walkthrough of the first one in terms of what it means, and then we'll just refer to a method in the subsequent questions. So in the first one, they want to simplify the ratios into their simplest form. So what exactly are we talking about initially? Well, we're talking about a ratio which represents 6 of one thing to every 9 of another, okay? So it could look like this. So we have 6 red beads, 2, for instance, let's take a different colour here, 9 blue beads, okay? And you can see I've distinctly written it in sets of 3, and we'll see why in a second, okay? So what I want to be able to do is say, well, actually, could I reduce the number down in both sides such that the same ratio is still apparent? Okay. So can we simplify it? That's what we're looking for here. So instead of 6 parts to 9 parts, could I divide my groups down to make them smaller and keep the proportions the same for both sides? Okay. So here's my groups of 3. What if I broke up, let's just change the color again, let's go orange, each of my groups of 3 into groups like this. Okay, so over here I've got 3 groups of 2, and over here I've got 3 groups of 3. Okay, so if we put a box around this one and a box around this one, we can see that for every 2 red counters on this side, I get 3 blue counters on this side. Okay, so actually then we find that our ratio could be written as 2 reds for every 3 blues. Okay, what have we really done? Well, we started with the ratio of 6 to 9 and said, oh, what's the proportion here? What's this? What can we break this down to? So I divide both sides into 3 blocks. Divided by 3, that side 2, 6 divided by 3 is 2, and 9 divided by 3 is 3. Okay, so 2 to 3, for instance, would be the same as 4 to 6. Okay, so if I double the amount of beads in this one, so if I add an extra row, then I would need to double the amount of beads, the blue beads as well, so I add an extra row. So now I'll get 4 to 6. Okay, and as long as I'm multiplying or dividing either sides of the ratio, or both sides of the ratio at the same time, then the ratio is the same ratio, or the numbers are in the same ratio. Okay, so here we find then our method, which is simply, can we divide both sides by preferably the highest common factor of both those 2 numbers, so 3 is the biggest number that goes into 6 to 9, or if we can't find the highest common factor straight away, we can make a couple of divisions. Okay, so these, for the first one then, we've got the answer of 2 to 3, and if you want to, you can just skip through, if you get this now, you skip through this and then just pause it when all the answers will be on the screen in a second. Okay, so for the next one, 10 to 5, so just write it underneath. Highest common factor of both of these is indeed 5, so I could divide both sides by 5, so there goes my method there. So this ends up being 2 parts to 1, and for this one we'll divide both sides by 7, and then we end up with 1 to 3. Okay, now what I'll do now is I'm going to pause the video and just pop the rest of the answers down there, so you have to watch me do them all. Okay, so there we go, you can see our answers underneath there. So 1 to 6, 3 to 10, 2 to 1 to 4, and 2 to 7 to 1. So you can add as many parts to this ratio as you want, as long as all the numbers stay in the same proportion, and it doesn't really matter. So we're looking for the lowest common, the highest common factor for all 3 numbers if we have a 3-part ratio. Okay, so equivalently we can multiply up, so the missing values for these equivalent ratios. So if 3 has been multiplied up by a number to get 12, that's going to be 4. So then if we have 4 times as many parts of the 5 as well, or groups of 5 perhaps we should say, we end up with 20. Okay, so we have 4 parts to each one group and 9 parts to each one group here. So we've times it by 3 to get up to 27, so we do the same to the 4 times that by 3, we get 12, and then finally 7 has been multiplied by 2 to get to 14, and therefore this becomes an 8. Okay, so next one talks about fractions. So the ratio of boys to girls in class is 4 to 5, so we've got 4 things on one side of the ratio and 5 things on the other. So how many things have we got in total? Well, I've got 9. Okay, so let's just add the two things together. So I've got 9 things in total. So I want the fraction of girls. Well, I've got 4 girls for every one part that I've got here, or for each group that I've got here. So the fraction would be 4 girls out of the 9 students in total. Okay, now there might be more than this. There might in fact be 18 students in the class, and therefore this fraction might be 18 to 8. I've just doubled both those numbers. If I simplified this down, the fraction would still come down to 4 out of 9 because the proportion is the same. Okay, and then I think we're at the end already, aren't we? So a model of a plane is made using a scale of 1 to 5. Okay, so in the real length, if the real length of the plane is 20 meters, what is the length of the model? Okay, so we're going to assume that the scale down perhaps, size is the 1 to real life, which is the 5. Okay, so for every 1 meter here, we get 5 meters in real life. So let's now place this underneath. My head's going to get in the way, isn't it? So we get 20 meters in real life. So that's 4 times bigger in the ratio. So my model is going to be huge. It's going to be a 4 meter model. Okay. So sometimes it's worth, when laying out a ratio question, put the words down first for what it's representing. Then put down the ratio we know, and then put whichever part you know afterwards. So we need the 20. That gives us the multiplier, and therefore we can place the 4 by multiplying the 1 by 4. Okay, so the wings of the model are 1.2 meters long. What's the actual length of the wings on the plane? Okay, so we're just going to do the same thing again. We'll run out of space. So we've got scaled down, let's just put SD, and real life RL. So that remains as 1 to 5. What do we know? The wings of the model are 1.2. So we place the 1.2 in here. Now we know we got to the 1.2 by multiplying 1 by something, which of course is 1.2. So now we're going to have to do the same to find the real life, so times that by 1.2 as well in the same proportion. So 5 times 0.2 is 1, and 5 times 1 is 5, so add the 2 together and we get 6. Okay, so I think the important, apart from simplifying the ratio, which is a relatively easy skill, the changing the ratio into a fraction is another really important skill for some of the questions later on. Okay, so hopefully that's been a bit of use, and maybe go back now and have a look at any of the Maths Watch questions you weren't able to do before.